Have you ever wondered how Google can analyze billions of records in just a few seconds? In this video, I'll take you behind the scenes of BigQuery, Google Cloud's serverless data warehouse. We'll explore why it's fast, why it scales effortlessly, and why companies trust it for mission-critical analytics. This session is designed for GCP certification candidates, data engineers, architects, and anyone building real-world analytics systems. By the end of this video, BigQuery will stop feeling like magic and start feeling logical.
Let's start with the problem. Traditional databases work well until data explodes. As data grows into terabytes and petabytes, teams struggle. You manage servers, you scale storage, you tune performance constantly. Google faced this challenge internally. They needed to analyze massive datasets, search logs, ads data, user behavior at a scale most systems couldn't handle. So Google rethought the problem from scratch. The result became BigQuery. So what exactly is BigQuery? In simple terms, BigQuery is a serverless data warehouse. You don't manage clusters, you don't provision machines, you don't worry about scaling. You load data, you write SQL, and you get results, often in seconds. All the complexity is hidden behind the scenes. That simplicity is the result of deliberate architecture. BigQuery works because of one powerful idea: separation of responsibilities. Instead of one system doing everything, BigQuery is built on 3 independent layers. Each layer does exactly one job and does it extremely well. Understanding these layers is the key to understanding BigQuery. Let's start with the storage layer. BigQuery stores data using Colossus, Google's distributed file system. Data is stored in a columnar format, not row by row. That means all values of the same column are stored together. This allows massive compression, less data scanned, and lower query costs. That's the foundation of BigQuery's efficiency. Next is the compute layer, Dremel. When you run a SQL query, BigQuery splits the work across thousands of machines. Each machine processes data in parallel. And here's the key insight: the data does not move. Compute goes to the data, not the other way around. That's why queries return so fast. The third layer is the network, Jupyter. Jupyter is Google's ultra-high-speed internal network. It connects storage and compute at massive scale, allowing BigQuery to function as a single system. Without this network, separating storage and compute wouldn't be possible. Most analytics queries filter and aggregate data. Columnar storage is perfect for this. BigQuery reads only the columns you need, aggregates compressed values, and skips everything else. The result? Faster queries, lower cost, predictable performance, even at massive scale. Analytics starts with data ingestion. BigQuery supports multiple ingestion patterns: batch loads for historical data, streaming inserts for real-time events, data flow for complex transformations, federated queries for external sources, transfer services for SaaS systems. The right choice depends on latency, volume, and complexity. Now let's optimize, starting with partitioning. Partitioning splits large tables by time. Instead of scanning years of data, BigQuery scans only relevant partitions. This dramatically reduces cost and improves performance. For large tables, partitioning is mandatory. Clustering takes optimization further. It organizes data inside partitions by column values. If you frequently filter by user, region, or product, clustering helps BigQuery skip data blocks. Partition for cost, cluster for speed. In production systems, you almost always use both: partition by date, cluster by frequently filtered columns. This pattern appears everywhere, in real systems, interviews, and GCP exams. BigQuery pricing mirrors its architecture. You can pay per data scanned or reserve compute using slots. But here's the key insight: table design impacts cost more than pricing models. Partitioning and clustering always matter. BigQuery goes beyond analytics.
With BigQuery ML, you train machine learning models directly using SQL. You can predict churn, forecast demand, and segment customers without managing infrastructure. For structured data, this is incredibly powerful.
Security is built into BigQuery. IAM controls access. Authorized views hide sensitive data. Encryption is automatic. Audit logs track everything. This layered model supports enterprise compliance by design.
BigQuery sits at the center of Google Cloud Analytics. Events flow through PubSub. Processing happens in Dataflow. Analytics run in BigQuery. Dashboards appear in Looker. This architecture powers real-time insights worldwide.
Imagine an e-commerce company ingesting 150 gigabytes of data every day. Events stream through PubSub. Dataflow cleans and enriches the data. BigQuery stores and analyzes it. BigQuery ML predicts churn. Looker visualizes insights. This is modern analytics in action.
In interviews, these questions appear repeatedly. Explain BigQuery architecture, partitioning versus clustering, real-time pipeline design, handling sensitive data. Now you understand the reasoning behind each answer.
Before we wrap up, avoid these mistakes. Not partitioning large tables, using select star in production, ignoring clustering, misunderstanding slots, no recovery strategy. Every one of these mistakes costs money.
BigQuery succeeds because of clear principles: separation of storage and compute, columnar data layout, automatic scaling, cost-aware optimization. Understand these, and BigQuery becomes intuitive. You're ready now. Practice with public datasets, experiment with partitioning and clustering, see the cost differences yourself. Hands-on experience builds confidence. Best of luck with your interviews and GCP exams. Welcome to BigQuery.